can imagine a player if you only track runs scored, you will miss out on strike rate. So number of sixes or how many times they are out. Likewise, in ML, different metrics can tell different stories. So predicting discrete labels, for example, spam or not spam, that would be cat or dog, like differentiating between any two specimens, that would be also there. So how often the model is correct overall, that determines the accuracy. So that is calculated based on this formula, and like it is used when the class are balanced or like you care equally about all outcomes. So we can avoid when one class dominates. For example, 95% is spam and 5% is not spam, and the precision also matters in this. So basically, what is precision? So out of all positive predictions, how many were actually correct? So this is calculated by using this formula. So for precision, fraud detection can be also example for this, because we want to be confident that the flag transactions are equally fraudulent, or hiring systems could be also one of the example. So you want to make sure that the selected candidates are truly qualified. So as you can think about precision, that it is a model as a metal detector, and like precision is all of alerts and how many actually found metal. So this would be the appropriate example for precision. So now moving forward to recall sensitivity. So out of all positives, how many did we catch? So that means the recall. And as per TP and FN, that is true positives and false negatives, that is the short form for both of them. So we use recall when we care more about false negatives than false positives. So for these scenarios, that would be disease screening. So you want to catch as many as cases if that is possible, even if the healthy people are flagged. And second scenario would be search engines, because you want to retrieve all the relevant documents even if some irrelevant documents show up. And third scenario would be criminal detection, so better to catch all possible suspects even if some innocents are flagged. Fourth scenario would be safety systems, that includes fire intrusion. So missing a real threat, that is false negative, can be dangerous. So we use recall when the cost of a false negative is high. And the formula is TP, that is true positives, and FN is false negatives. So for F1 score, it is the harmonic mean of precision and recall. So it ranges from 0 to 1, that is worst to best. And we use F1 score when you want a balance between precision and recall, especially when classes are imbalanced. Both false positives and false negatives are costly. For example, the scenarios would be test classification that would include sentiment and spam analysis, and classes may be imbalanced because it needs to balance between catching true cases and avoiding the wrong ones. So second scenario would be medical diagnosis with rare disease. So you want to find the real cases that is high recall while being confident, so that requires high precision as well. So for medical diagnosis with rare diseases is also one of the scenarios that uses F1 score. Of fraud detection is also a part of it, because we need to catch real frauds without flagging too many good transactions. So basically you need to use F1 score when you need a single metric that balances precision and recall, when especially an imbalanced data sets where accuracy is misleading. So this is the formula that will be used. So now regression metrics. So that includes mean absolute error, that is MAE. Basically, it is average of absolute differences between actual and predicted values, and it is easy to interpret same unit as target, and it does not penalize large errors harshly. We should use it when all errors are equally important. So here comes the root mean squared error. That basically average squad error penalizing large mistakes. So that it squares the errors before averaging. It penalizes larger errors more, and it is not in original units because it is already squared. So you can use it when you want to heavily penalize large errors. And for r square score, that is coefficient of determination. So it measures how well the model explains the variance in data. It ranges from 0 to 1, that can be negative to bad models, and you use it when you want to measure overall goodness of it. So for accuracy, the classification is the domain is classification, and it is best for balance sheets. So the key concern for this is that it leads to misleading on imbalanced data. Precision also has a domain of classification, so best for when false positives are expensive, and key concern is that it ignores false negatives. Recall has also classification domain, so it is best when false negatives are dangerous, and it ignores false positives. F1 is for also classification that is best for imbalanced data, and it is harder to interpret as well. Mean absolute error in the domain is regression. It is interpretable average error. So it is equal weight to all errors. Root mean squared error also falls under regression. So it is best for penalizing large errors, and it is less interpretable. And the last is R square score, that also falls under regression. It is best for measuring explained variance, and it does not show actual error. So over here we will be calculating accuracy score, precision score, recall score, F1 score, confusion matrix, mean absolute error and mean squared error, and R2 score, R square score. So part A is the classification matrix. And you can see the Y2 class and Y predicted class. That is the binary classification. So for accuracy score, we are using the function. For precision, we are using this. Recall, for recall, we are using this. For precision and for accuracy. And for F1 score and for confusion matrix as well. And part B is the regression matrix. So mean absolute error, mean squared error, and R square score. So after calculating the values, it came like this. After putting all the formulas, please go through the code. Uh, it basically works upon the functions and the formulas. So just presenting why it is important. So evaluating it. So, so now we will go ahead with introduction to Flask. So Flask plus ML integration, that is. So what is Flask? So basically it is a framework type that is very lightweight, minimal web framework is used, and the purpose for Flask is to build web applications, REST APIs, etc. And it is also flexible and it does not force folder structures or tools. And it is ideal for small apps, model deployment, rapid prototyping. So why do we use Flask with ML? So basically, it is easy to learn. It is simple syntax, great for beginners as well. API integration is also there, and it seamlessly wrap ML models in REST APIs. Real time predictions can be also done. It serves ML models to users via the web, and custom interfaces like you can add HTML forms for inputs, results, extensible. It is also extensible. It works with database authentication, frontiers, etc. But for Flask, the folder structures matters. You need to create a templates folder, and inside that only you need to place the HTML file, or else it will not work. So this is an essential step, because HTML files needs to be placed inside the templates folder. The basic folder structure for Flask is that. So app.py file is the main Flask app file, and over here iris model.pkl file is there, because in this the iris flower predictor has been used because of the small data set. So that's why it is named as irl model.pkl. So pkl file needs to be created after you save the model and train it. So automatically if you train the model, then the pkl file would be saved. So step 1 is that create index file with html with input form, wrote flask routes for and predict functions is there. So train model use logistic regression, or like you can save model using pickle, and load model and use predict dot in Flask, and return result of user via HTML. So Flask is a micro web framework for Python. It is light, flexible, and ideal for ML integration. So the core features for Flask is routing, templates, form handling, and easy deployment. So you, as required, you need to install Flask in your environment. So app root is the decorator that specifically binds the URL. So form from Flask import Flask, that is that this imports the Flask class from Flask module, and Flask is used to create the web application. Like you can think of it setting up the base of your website or server. So app is equal to Flask name. So here we are creating the Flask app instance, and underscore double underscore name underscore is a special Python variable that refers to the name of the current module. And Flask uses this to know where to look for templates and static files. So if you save this file as app.py, then double underscore name double underscore is equal to app. So, but when the script is run directly, then double underscore name double underscore is equal to double underscore main double underscore. So that is basically routing it to that. So when the script is run directly, then it is a function that has been performing. So app root. So basically this. So when the script is run directly, then it is like that. So app root. So this is a root decorator. It tells Flask when someone visits the home page, that is URL, run the following function. And slash is the root URL of your web app, like HTTP localhost 5000. So that is the root URL for that. And def home. So def home is the function tied to backslash root. So it is the view function, and it decides what to return when that root is visited. And the return hello Flask. So this line sends back plain text as HTTP response. So when you open your browser, you will see hello Flask. And the last one, if this one, so this block ensures that the app only runs when you execute this file directly. So it is a common Python pattern that prevents codes from running if the file is imported elsewhere. And app.run debug is equal to true. This starts the Flask development server. So debug is equal to true. That enables debugging mode that shows detailed error messages, automatically reloads the server when you make the code changes. So Flask name basically creates a web app. App root and the backslash that maps URL path backslash to a function. Home defines what to do on that route, and return is that it sends back content to the browser. And app.run launches the web server. So basically, so app slash name creates the web app. App root, that is backslash that maps URL path backslash to a function. Home defines what to do on that route. Return, it sends back content to the browser. App.run, it launches the server. So we need to train and save a model. So through that, if we save the model, then .pkl file will be created automatically. If we save the model, so model.py file will be created. So as you can see, the folder structure, as I have mentioned that inside the templates folder only index.html should be placed, and templates will be in lowercase itself. Then app.py is there, the app file. So what is render template also? Render template is a Flask function that is used to render an HTML file and pass data from your Python code to that HTML. So it looks for the HTML files in a specific folder that is named templates, I have mentioned, because this is very much required for the folder structure. Inside the templates folder only, the index file should be placed, or whatever the HTML file that you will name, that should be placed inside the templates folder only, because it is the basic folder structure that is required. So you can send the Python variables to your HTML page like this. So these methods, so this is used to define a new route, that is URL endpoint in Flask, that listens specifically for form submissions, or API that calls, or API calls that use the post method. So methods is equal to post accepts only post requests, that's form data or API data. And the predict over here is the URL endpoint. And the predict action is that runs when /predict is hit via post. So why do we use post over here? Because post is used when you send data to the server, that is, for example, form inputs, like any, like, as in this case, iris flower species is there. But get method is used when to retrieve data, not to submit forms. So because of that purpose, we are using post method over here, because when you send the data to the server, for example, over here we are using the HTML form, so that is the prime reason why we are using it. So but in the example that I will be showing, we will be using the hours, like how many hours you have studied, so it will predict that you have failed or you have passed. So this will be the templates index.html file. And what this, so basically this is used, like this is the Zinza 2 templating in your Flask HTML to display dynamic output, like model prediction conditionally. So this is a Zinza 2 conditional block. So it checks if the variable prediction underscore text exists and it is not empty or none. So the primary reason why it is being used is to check if the variable prediction underscore text exists and is not empty or none. And if it does, then the content inside the block is rendered. That means that it needs to be shown on the web page. And the prediction text, that is this one. So this is a basically Zinza 2 templating. So it checks whether the variable prediction underscore text exists and it is not empty or none. And if it does, the content inside the block is rendered and it should be shown on the web page. And this prediction underscore text, what it does, this is a placeholder for data passed from Flask. And the curly brackets tells the Flask to inject the values into the HTML, and in this case, the predicted hours will be like I'll be showing you in the example, and if. So the end, this ends the if block. So just like fi in shell scripting or closing braces in Python. So basically, why it is useful? Because it makes your web app dynamic, only shows results after a prediction is made, and it keeps the UI clean, avoids displaying empty or confusing text before submission, and it supports real-time ML interaction. So this is the model file. So it needs to be saved. Then when you will save this, then it will automatically create a .pkl file in the folder, and the folder structure should be like that inside the templates folder the index file should be placed, and this model.pkl file should be placed outside the templates folder, and the app.py file is over here. So basically we are going to predict if you're passing or you're failing. So this is the primary thing that what AppRoot does. That is a decorator that specifically binds the URL. So after, so study prediction app is there. So like the hour studies, if I put 5, then it will show you are passed. Again, it is coming past. When I'm putting 0 over here, then the prediction is failing. For 1 also, it is failing. So this is the Flask app.
Ma'am, I have a question. Is it mandatory that we have to make the dashboard related to our project using Flask, or can we use Next.js or Streamlit for using for building the dashboard?
You can use anything that requires, like, it is not mandatory that you need to use Flask only, just because like it is lightweight and like like friendly, user friendly. That's why I was suggesting, but you can use anything, even Gradio can be used.
Yeah.
Okay.
Thanks, ma'am.
So this is there. I will show the code once again. You can go through it. This is the app.py file for study prediction. So basically, the Flask name creates the web app, and app.root that maps the URL path to a function, and home is something that defines what to do on that route, and it return and the return part does that, it sends back the content to the browser. App.run launches the app server. And the render template is something that it keeps your app clean, that separates logic, that is Python, and presentation for HTML, and it loads and returns HTML from the templates folder, and it also passes the variables from class to HTML as well, and it uses Jinja too, so it allows dynamic content in HTML for variables, percentage for loops and logic. And about post and get, that is there for HTML. So post is used when you send data to the server, for example, that is inputs or the forms. So we are doing this over here, so that's why we are using the post one. But get is used to retrieve pages or data, so that's the primary reason why we are not using that over here. Once again, we will see the dashboard, then we will wrap it up. So we have created a study prediction app. So our studies. Okay, just wait a second. Okay, so it is working now. So only values under 5, I think. No, like only 1 or 2 it is predicting for. 2 also it is predicting fail. 3 also fail. 4, from 4 it is predicting pass. Like 4 onwards it is predicting the pass one.
Ma'am, will the output prediction vary, or does it remain same all the time? Like it is based on the model's accuracy or something.
Yes, yes, that is there. So according to the accuracy, it works. So we have used a small data set right over here, so that's why it has some limitations, but it will vary depending upon the data set as well,
Okay, okay.
and there will be some limitations regarding it.
Yes, ma'am.
So this is it for today. But guys, you need to make the dashboard for your project, so that will be really helpful to portray the project more efficiently. And you can use whatever platform that would be suitable for you. Flask is just one of them. That's why I have discussed it. You're free to use anything what is suitable that you find. And soon review will be also there. So please start preparing your projects very efficiently. It will be soon, as I have not received exactly when it is, but I think probably the next week we'll be having the reviews. Not so sure, but you will get a mail regarding it. So please start preparing for it. So that is it for today. Then we will wrap up the session today. Okay. Thanks.
Thank you, ma'am.